Here we're going to be taking a look at solving systems of linear inequalities. And how do you solve a system of linear inequalities in two variables? First, we need to know that the solution to a system of linear inequalities is an ordered pair xy that satisfies all the linear inequalities in the system. We have two steps that we're going to use to solve linear inequalities. First, we're going to graph each and shade where the answer areas are. Then, the double shaded area is going to be where the solution to both systems of inequalities is at. Let's look at an example. Here in blue, I've written that 3y is less than or equal to x. So I'm going to graph the line 3y is equal to x, because that equal sign is going to let me have a solid line. Placing it on the graph, I'm going to test the point 0, -5 to see if that's true. When x is 0, 3 times -5 is -15. -15 is less than 0, so it's true, and I'm going to shade below. Now for a green equation, I have that x plus y is greater than -2. I'm going to graph this using the x and y intercepts, and because it is not equal, it is not a solid line, but a dashed line. After graphing, I'm going to check the point 0, 8. When x is 0 and y is 8, 0 plus 8 is 8, and that is greater than -2, so I'm going to shade above the green dashed line. Where I see both areas are shaded, I've gone ahead and filled more in with red. That double shaded area shows the space where all the correct solutions are located. I like to ask the question of the point that I'm testing, is my xy in the shaded area? And if it is in the shaded area, then yes, I shade where that dot is. If no, then I shade away from that dot. Let's look at another example. Here I've written x plus 2y is less than or equal to a +6, and x plus 2y is greater than or equal to a -2. This is my system. So I'm going to graph the points, or the line in blue, of x plus 2y is less than or equal to 6. I'm going to do this using x and y intercepts and put down a solid line because I see an equal sign. I'm testing the point 0, 9. And when x is 0 and y is 9, then 0 plus 18 is not less than 6. So I'm going to shade away from that point I've chosen. I'm shading the opposite side of the line. For the green equation, x plus 2y is greater than or equal to -2, I'm also graphing that using x and y intercepts. I'm going to test the point 0, -10. When x is 0 and y is -10, 0 minus 20 is not greater than or equal to -2. So that point makes it false. So I'm going to shade away from that. I see that the double shaded area is between these two lines, and that's where all of my answers would be located. In order to check this, I could choose any point within there, like 0, 0, and see does 0, 0 make both inequality true. For the top inequality, 0 is less than or equal to 6, and for the bottom inequality, 0 is greater than -2, so it would be true. The quick brown fox jumped over the lazy dog for not doing their math homework.